Hey guys, so I'm going to do an example of an angle of elevation or depression application. So this problem was submitted by one of you. So a pyramid has a square base with sides 600 feet long and a height of 300 feet. So find the angle of elevation made from the sides from one of the corner to the center of the pyramid. So I have a little illustration here. So if you can kind of imagine, I did my best to draw this. All right, so this side here, so in here, there's like this measure theta. This is the angle of elevation that we're looking for. And so we've also been given a hint that the base of the triangle in the figure is half the diagonal of the square base of the pyramid. Okay, so I've been told here that my height is equal to 300, and then the base, so these sides here, these are 600 feet, and we're given this big hint that the base is half the diagonal. So I guess we should figure out what the diagonal is. So basically, if I figure out this length here, half of that will give me the height of like this triangle that's kind of erected in the pyramid. So hopefully that is making sense. Okay, so let's just go ahead and do this then. So my diagonal, really, this is when you look at this is just a right triangle, right? So this side, and then the diagonal. So I'm just finding the hypotenuse. So I can take 600 squared and 600 squared and then take the square root of that. And so that's going to give me, that's going to give me 600 times the square root of 2. So then if I take half of that, that will be the base of the triangle. So that comes up to 300 times the square root of 2. Okay, so now actually, like when you look at this, we know that this little height here, so maybe I'll mark it nice and clear. This will be 300 times the square root of 2. So this height here is 300, and then this here is 300 times the square root of 2. And so I'm trying to find theta, and so you'll notice, right, I know the opposite and the adjacent, so we're going to use tangent here. So I've got tangent of theta is going to equal 300 over 300 times the square root of 2. So then I just get that tangent of theta is equal to 1 over the square root of 2, and now I can just take inverse tangent. So my theta will equal inverse tangent 1 over the square root of 2. So I get 35.26 feet in this case, and then adjust that, of course, if you've got to use significant figures or whatever. Okay, and so that's it for this one. So that is how you can approach that problem. So thanks for submitting that one. I'll talk to you guys in the next video.